In the second video for Lesson 1 of the second section, we will consider how subtraction can be used in the preservation of equality. Let's have a look at our balance scales and the idea of subtraction. Keep in mind that whatever I subtract or take away from one side, I must subtract or take away from the other. Here's our two-pan balance. So we've put on our balance here a mass of 8, 5, and 1 on the left-hand side. And on the right-hand side of our balance, we have a mass of 10 and a mass of 4. On both sides, we have a total mass of 14. So that's why it's leveled off. We're going to remove something from the left-hand side. We're going to take away that mass of 5. We remove that mass of 5. That makes the left-hand side lighter, so the scale dips down to the right. If we want balance back, well, we got to take away a mass of 5 from the right-hand side. Well, right now on the right-hand side, I have a mass of 10 and a mass of 4. So what I can do is take the mass of 10 and break it down into 2 5 masses. There we go. But even still, 8 plus 1 doesn't equal 5 plus 5 plus 4. I still haven't removed a mass of 5. So let's do that. So if I remove that mass of 5, balance again. 8 plus 1 does indeed equal 5 plus 4. A second example with balance scales. Here's a linear equation. 2y plus 3 equals 5. On the left-hand side, we're going to put our 2y plus 3. And on the right-hand side, we have our 5. So my LHS, 2y plus 3. My right-hand side, my RHS is 5. Here we're going to take a mass of 3 away from the left-hand side first. So if I take away that mass of 3, I'm just left with 2y. Once again, because I've removed the mass on the left-hand side, it makes it lighter, so my scale tips down to the right. In order to balance everything out, I got to somehow remove a mass of 3 from the right-hand side. Right now, I have a mass of 5. So what I do is I take that 5 and I break it down into a mass of 3 and a mass of 2. There we go. And now we can take away the mass of 3 from the right-hand side. When I do that, balance again. And our equivalent equation is 2y equals 2. So my left-hand side is now just a 2y. My right-hand side is now just a 2. And our second model, algebra tiles. Whatever I subtract or take away from one side, I must subtract or take away from the other. 3p plus 4 equals 10. Let's represent this using our algebra tiles. So we have 3 variable tiles to represent the 3p, 4 unit tiles, and that takes care of the left-hand side. On the right-hand side, I have 10 unit tiles. And of course, this little symbol here represents my equality. Now, what are we going to remove? We're going to write an equivalent equation by subtracting or taking away 3 unit tiles from each side. There's the original. These are the 3 unit tiles I'm going to remove. There they go. Now, what are we left with? Symbolically, we're left with 3 variable tiles, which gives us the 3p. We're left with 1 unit tile, which gives us the plus 1. That takes care of the left-hand side. And on the right-hand side, we're left with 7 unit tiles. So 3p plus 1 equals 7 is an equivalent equation to 3p plus 4 equals 10. If we were to solve, both equations would result in the same solution. And one more. 5 equals 2 plus n. 5 equals 2 plus 1n. If there's no number directly in front of the variable, it's understood to be a 1. Let's represent 5 unit tiles on the left-hand side, a variable tile, and 2 unit tiles on the right-hand side. What are we going to take away this time? We're going to subtract 2 unit tiles from each side. So I'm going to circle 2 on each side, remove them. Let's get them out of there. What are we left with? On the left-hand side, we're left with 3 units. On the right-hand side, we're left with 1 variable tile. So n equals 3. This would be an equivalent equation for 5 equals 2 plus n. In fact, I'll let you in on a little secret. We actually just solved this particular equation. N equals 3 is indeed an equivalent equation, but it's also the solution to this one. Pretty cool. And now I'd like you to proceed to the activities for Lesson 1.